happy to see you again in this occasion. Now, we will learn about system of linear equations. With me, Ariyani, with the last three-digit number 013. Without wasting many time, so let's get started. Who's know and understand what is the letter talking about? Let's do some review of some very important vocabulary terms when we are talking about algebra. Coefficient is a number that describes the number of similar variables. This coefficient is located in front of variable. Variable is substitute numbers whose value is announced. Variables are usually denoted by letters such as A, B, C, and so on. A constant number value that is not followed by variable behind it. Term part of an equation consisting of variable, coefficients, and constants. But in this video, I'm not just talking about this. I will explain about system of linear equations, the types as the three. First, system of linear equations, one variable. Two, system of linear equations, two variable. System of linear equations, three variable. And in this system of linear equation, there are applying in the real life, in our life, right? And there are 5 methods on systems of linear equations. There are graph, substitutions, eliminations, blended, and determinant. So, for the first one, is a systems of linear equations in one variable. As the name implies, systems of linear equations in one variable contains only one variable with the power of 1, which is in the form of an open sentence connected by an equal sign. The open sentence here means a sentence that does not know the truth, or it could be true or it could be wrong. The general form of the one variable linear equation is ax plus b equals o. For this information, a is coefficients, b is constants, x is variable. A and b are real numbers. A and b are not zero. However, what needs to be underlined is the variables don't always use the symbol x. They might use y or something else. For this example is 10x plus 2 equals 22. X equals 22 minus 2 by 10. So we have x as 2. Okay, next, for this system of linear equations in two variables. As the name implies, system of linear equations in two variables is a system of equations with two variables with the power of 1. The two variable linear equations use the equals relations, and there is no multiplications of variable in each equation. Without realizing it, this linear equation of two variables is usually used to solve simple problems in everyday life, especially in buying and selling activities. Usually, this equation is used to find profits. The general form of linear equations of two variables is ax plus by equals c. The linear equations of two variables can be solved by two methods, namely the substitutions method and the eliminations method. The substitutions method is using by changing one variable with another equations variable, while the eliminations method by removing one of the variable in the equations. For this example, 2x plus 4y equals 12 and 2x plus 2y equals 8. Okay, what are the x and y values? Okay, for the solutions to system of linear equations in two variables, and there are one unique solutions, no solutions, and infinitely many solutions. For the example, the next is solves the system by paragraph both linear equations and finding the point as in intersection. Y equals negative 3 by 2x plus 1 by 2. 2x plus 3y equals negative x. For the solutions, to graph each equations, write the equations in slope intercept form y equals mx plus b. First equations you can look at the slide, and the second equations you can see also. For the slope intercept forms, we see that the lines have different slopes, indicating that the lines must intersect at exactly one point. Using the slope and y-intercept, we can graph the lines to find the point of intersection. And this is the graph, and you can get the solution is 3, negative 4. Okay, the next is systems of linear equations in 3 variables. The 3 variables linear equations is an extended form of the 2 variables linear equations. These equations can also be solved by 2 methods, namely substitutions, eliminations, and the new is determinants. This system is usually used to determine the point of intersections, and it is useful in things like construction, buildings for more precision. The general form of the 3 variable linear equations is ax plus by plus cz equals d. For the examples, solve the systems 2x plus y minus 3z equals negative 7, 3x minus 2y plus z equals 11. Negative mean 2x minus 3y minus 2z equals 3. For the solutions, step 1. The questions are already in standard form. It is often helpful to label the equations. The y variable can be easily eliminated from equation A and B and from equations A and C. This is accomplished by creating opposite coefficients for the y terms and then adding the equations. Step 2. You should to be eliminate the y variable from equations A and B. And then you can eliminate the y variable again, this time from equations A and C, and you will get equations E. For the next step is, now equations D and E can be paired up to form a linear systems in 2 variables solve these systems. For the next steps, now that 2 variables are known, substitute these values for x and z into any of the original 3 equations to find the remaining variable y. Substitute x equals 1 and z equals 2 into equations A, and check the order triple in the 3 original equations, and we will get some true with the in these three equations. The next example is solve the systems if there is not a unique solutions. Label the system as either dependent or inconsistent. The solutions seems like before that, and we will get the results O equals O to indicate that there are infinitely many solutions and that the system is dependent. The next one, this use determinant, solve the systems by using Cramer's rules. The equations are x minus 2y plus 4z equals 3, x minus 4y plus 3z equals negative 5, x plus 3y minus 2z equals 6. For the solutions, you can see in this slide. Okay, in this case, you will get sums x equals 1, y equals 3, and z equals 2. For the solutions is 1, 3, and 2. We should check the next step. And this is true. Okay, the next is, what are the applications of linear equations? So the applications in real life, the applications of linear equations are vast. To tackle real life problems using algebra, we convert the given situations into mathematical statements in such a way that it clearly illustrates the relationship between the unknowns or variables and the information provided. The following steps are involved while restating situations into a mathematical statement. Translate the problem statement into a mathematical statement and set it up in the form of algebraic expressions in a manner that illustrates the problem aptly. Identify the unknowns in the problems and assign variables. It is about quantity whose value can change depending upon the mathematical context to these unknown quantities. Next one is, read the problem thoroughly multiple times and guide the data, process, and keywords. Organize the information obtained sequentially. Next one is, frame an equations with the help of the algebraic expressions and the data provided in the problem statement and solve it using systematic techniques of equation solving. Next one is, retrace your solutions to the problem statement and analysis if it suits the criterion of the problem. Okay, applications of linear equations in real life. First is, you find a known age, find known angles in geometry, for calculations of speed, distance, or time, and problems based on force and pressure. Let us look into an example to analyze the applications of linear equations in depth. Applications in linear equations solve example. For examples, Rishi is twice as old as Fanny. 10 years ago, his age was trace of Fanny. Find their present age. For the solutions, in these words, problem, the age of Rishi and Fanny are announced in quantity. Therefore, as discussed above, let us first choose variables for the unknowns. Let us assume that Fanny's present age is x years. Since Rishi's present age is 2 times that of Fanny, therefore, his present age can be assumed to be 2x, 2 times x. 10 years ago, Fanny's age was 8. Okay, I think that's all for me. So, see you next time. Thank you. Goodbye.